Okay, so let's start with our ongoing course, circuit simulation on a Matlab. And previously, we have been stuck in the oscillator part of the course. So let's try to complete that part, and after that, we will go towards the project part. So let's start the course. Oscillator circuit. The previous circuit took advantage of negative feedback. Okay, so because of negative feedback, the gain of the amplifier stays stable and the output remains stable. So it will increase the load efficiency as well as the output impedance will be stable. Now, on the other hand, can be used to drive the oscillator. Okay, so positive feedback can be used to drive the oscillator means if we have to make a oscillator like RC or phase shift or uh, Hartley oscillators, we need BJTs, but they are not that much efficient. That's why we need a different type of approach where the IC741C, which is nothing but operational amplifier, comes, and it is much more stable than that Hartley or crystal oscillators. Okay, so using positive feedback signals as a small thermal noise are repeatedly amplified up to supply voltage of the operational amplifier, that is oscillators. Then oscillator generate repetitive waveforms such as sine, triangular, or a square wave. So I have created one oscillator known as the schematic trigger, where the oscillations goes from plus saturation to minus saturation as per to the threshold of low threshold and high threshold, and we can manage the value of threshold by giving the sine signal. So it is not like a proper oscillator, it is like a sine wave to a square wave converter, where when the voltage from of a V in goes below or above the threshold, the rectangular wave will change its nature. Okay, so oscillator is a circuit where we don't need to give an external input like V in. Basically, we don't need to give an input like a sine wave or anything else. It's just work on its own input. So what we have to do here, you can say in a circuit there are two types of feedback, that is positive feedback and negative feedback connected to a amplifier in inverting and non-inverting terminal, and the both inverting and non-inverting terminal are grounded. So basically what we are taking basically we are taking the advantages of input offset. So we will not go in that deep direction in electronics, we will just go throughout the course and learn about the oscillators. Okay, so let's start with the course, because deeper you go in electronics, the more you know about how much you don't know about electronics. It's like a paradox. Now, yes, allow. Next. Now, add a band limit op amp. Okay, so I have to add band limit op amp. Why my interconnect connection is not working? Yes, now it's good. So, band limited op amp, which is this block. What do you have to do? You have to set the maximum output and maximum input to the specific voltage of minus 10 and 10, minus 10 and 10, and the output resistance should be 0.1 to increase the input, sorry, to decrease the output impedance. And the maximum slew rate is nothing but a rate of change of output on rate of change your output according to the input, that is a slew rate. Okay, slew rate has to be in 1e6, means 1e6. 1e6 is nothing but a 10 raised to power 6 volt per second. Okay, because it is a rate of change of output volt based on input volt, like that. Now add a resistor and capacitor block. Resistor and capacitor block, a foundational library, and set the value of resistance to 100 ohms, 100 ohms, and set the value of capacitor to 10 microfarad. 10 microfarad. Next, add two more resistor block and set the value to 10 raised to power 3, that is 10e3. 10e3. It's ohms or kilo ohms? It's ohm. Okay, that is set to ohms. Register 1 and register 2, copy, paste. After that we have to make the connection. That task is make the connection for the circuit as shown in the diagram. First we need to add the band limited operational amplifier. After that we have to add a feedback of 10 ohms at each inverting points. So basically you can add like this, just output like this. Then in the positive terminal we have to add the 10k resistor. In the negative part, sorry, positive part, okay, in positive part we have to add 10k resistor, and in negative part we have to add the capacitor. Then both capacitor and resistor are connected to the reference. Okay, okay. Select and expand the capacitor and set the capacitor voltage to 1 microvolt. 1 microvolt. It's MV or MV? It's MV. Microvolt. And the priority is already set to high. Does the select and expand the capacitor voltage option and set the voltage to 1 microvolt, set millivolt. The priority is already set to higher parameters. Does the following block match the value? It is set to 10 microfarad. I think it's perfect. So the solution is set to 1 microvolt. Capacitor value is already initiated. We specify on. Okay, so let's go to the capacitor parameters, where we have to macro. Okay, let's set to 0. Priority is set to high, value is 1. So macro volt. signal is also perfect. Ten microfarad. What's the problem? Uh, why it is giving me the problem? Okay, let's add a new capacitor block. After that, we will set the value to 10 microfarad, and we will go to initial target, set the capacitor voltage to 1 millivolt. 1 MV. Okay, then we will run the simulation. Why it is not working? The value is set to 1 microvolt in to the positive, even a small value is obviously set to 1 microvolt. Still, it's give the same error. Should I have to use 1 here also? Then microfarad. Is it millivolt or megavolt? Okay, if why am I getting this type of error? Does the following block matches the value plotted required? Capacitor V. What should I choose? 5. Then 10 microfarad problem. Okay, so we will we have to go to the YouTube, and then we have to understand that what is the root cause of this error. Otherwise, it will be difficult for me to understand that what is going on in the code. This simulink on RAM. I need a circuit simulation on RAM in Matlab. Isn't there any circuit simulation video?
in un sistema molto facile da comprendere, dobbiamo al blocco e quindi C. Noi possiamo Matlab R uguale a 5, riclicchiamo.
Simulink on RAM. I don't need simulink. I need circuit simulation on RAM. Simulation. Electrical system. Nope. I need a proper circuit simulation course. Simulation. I need a proper circuit simulation. This is the video that I have created 16 hours ago. So there are a lot of videos. Okay. Does the following block matches the value plotted required? Where is my signal? I can't even see my signal. Assessment is perfectly done because you can see that does the following block have the correct parameter setting? Yes. There is nothing else that I have to do, and without this I can't go to 6 task. It's frustrating. No, what is problem causing? Okay. Oh, what is the root cause of this error? Yeah. You can see I have set it the value, everything is perfect. Why am I getting this error? I don't understand. So we will look for this in another task. Okay. So in another video, I will complete that part. Let's go towards the project. Let's make our own oscillator in a Matlab. Obviously, the oscillator is not fully. Hmm. Project Vein Bridge Oscillator, where we have to use a positive feedback with a capacitor and a negative feedback without a resistor and capacitor. And then we have to use the RLC circuits. No, this is RC circuit, and at the output there will be another feedback. Okay. Now add a two resistor block and the capacitor block. Resistor and capacitor. Resistor and capacitor block. Set the value of resistor to 100 to the power 3 kilo ohms. And the value of capacitor will be 3 e minus 9 microfarad. Am I right? Or it's picofarad? No, minus 3 farad. Okay, there has to be two dots now. Next part. For one of the capacitor blocks, you use initial target and set the value of capacitor to 1 volt. Next. Now connect the circuit like this. Okay, so this will be our one circuit. So this will be our resistor and this. Now this can be in parallel connection with the reference ground. Let's connect the circuit. Again, it has to connect the ground. Further configuration attached. Next. What is the problem here? VC 0. I जूम भी नहीं कर पा रहा हूँ यार। जूम क्यों नहीं हो रहा? V, sorry, V C bracket 0 colon 1 वोल्ट। ठीक है, अभी शांति। ये यार, ये क्या प्रॉब्लम है, मेरे को समझ में नहीं आ रहा। असेसमेंट गलत, असेसमेंट गलत, तो क्या वापस जीरो डालू अभी मैं? अभी जीरो डालू क्या वैल्यू में यहाँ पे फैरेड की जगह पे? क्या था, मैं तो वो भी भूल गया यार। 1 वोल्ट पे है ये, ठीक है। और ये कितना था? 3 e - 9 फैरेड। और इसको करना है इनिशियल पे 0। अब तो होगा। अब ये हुआ। बाप रे बाप, दिमाग खराब हो जाता है भाई कभी कभी सच में ना। Add an operational amplifier. Sorry. Add an op amp and 2 more resistor block. All blocks should be from the sim space. Op amp and 2 more resistors. Now add the op amp like this. We need to add op amp like this. Okay, and this has to connect it to referral ground. Set the value of resistor. So the value of resistor has to be 100 e to the power 3 ohms, and the other resistor has to be 100, sorry, 50 into e to the power 3 is nothing but a 10. Now connect the RF connect RF and RG. Now what I have to do, I have to take the non-inverting part, I have to connect that non-inverting part to this set. ओके, ठीक है। और इसका जो ये वाला लेआउट है जो कि रेफरेंस जा रहा है, इसको काट के we have to attach it here. And yeah, that's all we need to do. Okay, so let's see first. As it is perfectly fine. Why should I have to use a different type of reference block? Electrical reference. Still. Okay. We need a voltage sensor block. The foundation library. Add a voltage sensor block and the PS simulink converter and a scope block. And what I have to do, I have to connect this, and then I have to connect. Where should I have to find the voltage? Connect this circuit such that you can visualize the op-amp output voltage indicated by V out. So the plus has to be here and minus would be on the ground. Let's see. Yep. And we can see the scope now. So this is the perfect signal that we have generated. It is a perfect, not perfect, but it is a sine signal. Okay, not perfect, but still it is a sine signal. Next task, the feature section. With this we have technically completed the course, but because we have stuck at one point, I have to so with this we have completed the course. Now we will go towards the course again, and we will complete that left it part, and with that we can complete 100% course without any portion left behind. Okay. So now oscillators next.
Electrical filters are everywhere.
It's this part, oscillators in the manual. It will take some time, and after that we can move to the next course, which is electrical power simulation. It's one of band limited op amp has to be set like -10. Here just need to set it at 10. The output resistance is 0.1 ohms, 0.1 ohm. And slew rate will be 26, 1e6. Okay, submit next. Resistor and capacitor. Foundation library. This is set to 100 ohm, and this is set to 10 microfarad. Next, add two more resistor block and set to 10 ohm. Oh, sorry. E3. format, we will go to the flip part. Yep. Flip part. Then we have to add a capacitor. We'll see the solution. Minus, minus. Okay. After that, we have to add a plus here. No, this is not a 10k resistor, no? This is the 10k resistor. So we'll add this 10k resistor here, and we will take the output like this. We will add one more 10k resistor. Plus one. And the minus will go towards the ground. Solver configure. Next, what we have to do? We have to हाँ, अरे तो गेट खुला है ना, सीडी वाला है ना, ऐसे उंगली डाल के खुल दो, खुल जाएगा। मैंने बोला बंद मत करना, तो बोले कि बंद नहीं कर रहा, मैं ऐसे ही लगा देता, उंगली डाल के खुल लेना। खोल लो, जा। खुला नहीं है, कड़ी लगी है, ऐसे उंगली डालूंगी, वो ऐसा अटका के नहीं रखा है। नहीं, मैं खोल दूं क्या? खोल दूं क्या मैं?
Electrical filters are everywhere.